Okay. Now, status of motion related to the net force. So here we want to look at status of motion. So in physics, you must understand what's the meaning of status of motion. Status of motion, right, is in reference to the condition of a moving object. When an object is moving, all right, how is it moving? All right. So in physics, we must have a way to describe the motion. So normally at your level, the status of a motion, okay, can be described as, is the object moving at constant velocity? All right. Is it moving at constant velocity? That's the number one concept. Then the second one is it moving at constant acceleration? So which is which? Of course, it can't do both at the same time. It's either one. So an object, the status of motion of an object could be it's moving at constant velocity. It could be moving at constant acceleration. And are there other possible status? Of course, there are other possible status. It could be moving with acceleration, which is increasing. It could be moving with acceleration, decreasing. So they are other than that, but we're not going to explore that. We are going to limit our status of motion to these two conditions. All right, but there are other possible status of motion, as I just mentioned to you. All right, it could be is accelerating, okay, with an increasing acceleration. It is accelerating with a decreasing acceleration. It can be decelerating with an increasing deceleration. It can be decelerating with a decreasing deceleration. So there are many, many options which we are not going to explore that. We are only going to explore these two. Now, besides this, there is another status of motion which many of you do not realize. Okay, being in the state of rest or being in a stationary condition is also considered as a status of motion. So being stationary or if an object is at rest, it is also considered as a status of motion. So in fact, there are three. All right. Okay. Now the next thing is, when does the object exhibit this status of motion? So all this depends on the net force that is being exerted on the object. The net force. It depends on the net force. Okay. Now, stationary and constant velocity. The condition will be net force must be zero. Okay. Your net force must be zero. Only then the object can be in a stationary position or moving at constant velocity. Now, in a constant acceleration, your net force cannot be zero, which means your net force must have a positive value. Okay, it must have a positive value, cannot be zero. All right, but there's another condition. The net force must also be constant. That means it cannot be a changing net force. That meaning, let's say the net force is 4 Newton acting on the object. Throughout the motion of the object, the net force must be 4 Newton. So it must be a constant net force. So it must be a constant net force. That's what we're talking about. So it's 4 Newton throughout 4 Newton. It is 6 Newton throughout 6 Newton. It is 10 Newton throughout 10 Newton. Then only you can have a constant acceleration. Otherwise, the acceleration will be changing. That is where you have, if the net force is an increasing net force, I just put here, if the net force is an increasing net force, that is when you will have increasing acceleration. The acceleration will be increasing. If the net force is a decreasing net force, that means it's not constant. In both cases, it's not constant. So that means the net force is there, but the net force is decreasing. That means the net force was at a very high value, but as the car is moving, the net force is decreasing. That means, let's say at the beginning, the net force is about 20 newtons. Then as the object is moving forward, 20 newtons drop to 18, 18 drop to 16, 16 drop to 14, and so on. So accordingly, the acceleration drops. This is what we call decreasing acceleration. In this case, the net force could have started with 8 Newton. As the object moved forward, 8 Newton net force, increase to 12 Newton net force, increase to a 50 Newton net force, increase to a 70 Newton net force. Accordingly, the acceleration also increased. That's how you get the increasing acceleration. Okay, so both this situation indicates the net force is not constant, so decreasing acceleration. So both this means net force not constant. All right. So here, in order to get a constant acceleration, two things: net force cannot be zero, condition number one. Condition number two, the net force must be constant. All right. For stationary, the net force must be zero. All right. And constant velocity, net force equals to zero as well. And this is condition number one. This is condition number two. But what's the difference between them? See, both net force zero, but the status between them is different, not the same. This is the net force is zero, and the object initially is at rest, or initially the object is stationary. That means the object initially is at rest. Initially it was stationary, and the net force is zero, so it continued to remain in rest. Here, the net force was initially moving. Initially moving. That means the object is already moving. Initially moving, and then it attained a net force of zero. Initially moving, and then it attained a net force of zero. All right. So initially, when it's moving, it could be accelerating, it could be decelerating, doesn't matter. Okay. But when the moment the net force became zero, it was traveling at constant velocity. So this is the point number two shows the difference between the two states of motion. All right. Now, have you captured all that I've said? So that means if you want to do any calculation, or if you want to do any studying of the status of the motion, you must remember in any motion, an object will be subjected to two groups of force, or two types of force, known as the motive force, which is the force that initiates motion, maintains motion, causes motion. Then on the other hand, you have a resistive force. That force opposes the motion, which means it opposes the motive forces. All right, there are two types. So your job is to recognize which force is the motive force and which force is the resistive force. Remember, motive force and resistive force are terminologies, ideas. They are not the actual force that is acting on the object. The actual force that acts on the object are forces like pushing force, pulling force, air resistance, water resistance, tension, weight. These are the forces that actually acts on the object. You got to look into these forces, look into the direction of motion. That means how the object is moving. Based on that, now you got to group them. Is the weight a motive force, or is it a resistive force? Weight can be a motive force, weight can be a resistive force. Depends. But your air resistance can never be a motive force. It's always a resistive force. Your frictional force can never be a motive force. It's always a resistive force, because by definition, resistive forces such as frictional force and air resistance by definition opposes motion. Therefore, they have to be resistive forces. Now, a pulling force can be both motive, can be resistive, depending on the direction of the pulling force with respect to what? With respect to the direction of motion. This is what I'll explain shortly. Okay, and then you have the thrust. Thrust is a force that is generated by any objects with an engine. All right, like a car, for example, there's a car, the force exerted by the car engine, we usually call it as the thrust. Okay, these are some of the forces that actually exist. Your job is to classify them as motive and resistive based on the action of the forces compared to the direction of motion. Now, how does that work? If a force is in the same direction as the direction of motion, so design the direction of motion, look at the force, see what direction is acting. Is it supporting the direction of motion? That means, is it in the same direction of motion? Then classify it as what? Motive force. it has to be a motive force. But if you see a force acting opposite to the direction of motion, that means it's not supporting the motion. Therefore, it has to be the resistive forces. So this is the basis under which you classify forces as motive and resistive. So we are going to look at some of the examples. So in each example, I'll show you how to spot a motive force and how to classify a resistive force, and that will come into our calculation. All right? Okay. Now, so these are the two forces I was talking about. So our calculation underpins on this. You take the motive force, you minus the resistive force. So what have you got? If you take a motive force, you minus the resistive force, you have what we call a net force. Now, many ways to look at it. So let me give you a value. Let's say the motive force is 10 newtons and your resistive force is 6 newtons. So one way of viewing this is, okay, a 10 Newton motive force is trying to cause an object to move, all right? But at the same time, a 6 Newton resistive force is trying to oppose the motion. So what is the 10 Newton motive force is doing? It uses 6 Newton of its force to neutralize or to cancel off the 6 Newton of the resistive force. So from this 10 Newtons, the motive force uses 6 Newtons and cancels that and neutralizes that, which means there are no more resistive force after the cancellation. So after the cancellation, there are no more resistive forces. So what's the value of the motive force now? After the cancellation, the motive force drops to 4 Newton. And that 4 Newton is now the force, the only force that's acting on the object. That's one way to look at it. And therefore, it becomes the what? The net force. That is how this system works. Okay? And this is equal to MA. So the net force will be equivalent to the product of the mass and acceleration. So this will give you a way to calculate the acceleration, and this is our fundamental formula to calculate our acceleration. Okay, from now on, we're going to look at a few examples and to see how we apply this formula. Okay, let's now go to our notes.